everybody, how are we doing? Make sure I think I got the stream going in the background. Oh, here it is right here. Wait, should be live. Here it is right here. Oh, there we go. Good deal. We are up and going. Do I have the audio going in the background? I make so many changes. Had to get a few things fixed up. We do have the audio going. Of course we do. I think we'll be doing some clustering to start and then some chapter 7. You bet right there. We've got right here. Sorry. Oh, gosh. Sorry. Today I've been like congested this morning. It's just like fall break couldn't get here soon enough. So we've got here the visualization 5 right up. Like, can you demonstrate what you are looking for, the written portions? Yes. Let's look at that first. First question right here. And then we're going to do some clustering and then some chapter 7. So let's go take a look at the visualization. So we covered this a little bit last time, so I'm going to kind of mention through the notes right here. Let's talk about what you need for your write-ups for visualization number 5. Let's go take a look at that. So we've got here, and we covered this in the last video, so take a look at that one where we walk through how to make this graphic right here. You need to make sure you have your scatter plot. You need to make sure you have your summary right here with your model in here. This is not your model, but it should look something like this. And then you need to have the parameter estimates down here. Very important, where you have the significance down here at the bottom. So this is where the significance is at. And then now you need also, make sure to include this, the diagnostic plots with the residuals down here. So this is added by going to the red arrow and clicking on the linear fit, and you will get the options. The linear plot is added by the red arrow up here, and make sure you check out the last video where we go over this and we kind of walk through these parts too. But with this, when we go down to our conditions, what are the conditions for regression? How do we remember them? Practice right here in the chat with me. Let's make sure MuBot's awake. What are the conditions for regression? What are the conditions for regression? This is good practice for the test. There's a new one. So what are the 4 conditions for regression? You can see them on the screen, but what do we have as the 4 conditions for regression? What are the 4 conditions? We like to say it a certain way. Something, 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 no this, or plot doesn't this. What are our 4 conditions for regression and how do we say them? So this is really good practice right here to make sure you know the 4 conditions. The first 3 are the conditions for correlation that we were covering for last test. And then we had a 4th one that you can see right here, but practice saying them in the chat right now. You'll do a lot better, I promise. You write them down, you practice them, you make sure you say them, because I can say them all the time. I can say QQ straight enough, no outliers, plot doesn't thicken, QQ straight enough, no outliers, plot doesn't thicken. And then I have to say, great job right there, Tiffany, excellent work. And what does this mean? QQ means both of these variables are quantitative. And I want you to see how I'm doing this right up right here. You can kind of copy this style right here. I didn't want to fill out everything because I want you to look at your plots and see what makes sense to you. QQ is asking, are both your variables quantitative? Well, if you have a scatter plot, they are. We're asking now, is it straight enough, which is going to evaluate this line and see if the line goes through the center of the data. Is that straight enough? It probably is. And then we're asking, are there no outliers? And this one is not met. Notice how I've kind of highlighted that for the grader. Grader's going to be really happy. And we see some outliers. I did mention explicitly this individual right here. And that individual right there is someone with about 45 weekly hours reading and 3.0 GPA. So I kind of went through and explicitly mentioned them. And last but not least, I'm so congested, it sucks. And last but not least, we have plot doesn't thicken, which I think is not going to be good right here. You can also see the plot thickening issue, which we don't want to see a thickening plot, which we see especially in those areas there. You can also see it down here in the residual plot, where you have this sort of here. We see that outlier too. So the residual plot is going to help us examine things like plot thickening. So I'd say there are some minor issues here. You can say major, minor. I think there's no issues. But look at yours to see if you see issues with plot thickening. And plot thickening could be getting smaller or thicker in any direction. We just want the same thickness throughout. So make sure to be very explicit in answering, are the 4 conditions met right here? It does thicken, yep. So that is not good. We want the plot to not thicken. We want it to stay same thickness throughout. When we go down here to the slope and intercept interpretation, make sure on the test especially to give context. So when you do the intercept, it's when x is equal to 0. That's why we call it B0. That is when x is equal to 0, we expect y to equal B0. We have to ask ourselves, is this logical? Well, in my example right here, the intercept is estimated to be 6.09. So 6.09 is the estimate of the intercept, which would state when someone has a high school GPA of 0, might not be logical, then we would expect the weekly hours reading for this individual to be 6.09. So I don't know if it's really that logical because it doesn't sound like you'd have a high school GPA of 0. So maybe not logical. When it comes to the slope, and this is where people lose a ton of points on the test, the estimate for the slope is B1. Sorry, everybody. There we go. There's the equation. And you can see the components above it. We are currently highlighting B1 right here. And it's a very small slope. So for each 1 unit increase in somebody's high school GPA, we expect their weekly hours reading to increase by 0.5. Sounds larger than it is. It doesn't look that big. It's just there's a lot of variation in this. And GPA only goes up by like 2.5 units. So it's only changing it by about 1.5 units. So remember, for each 1 unit increase in somebody's high school GPA, that's what the X is, we expect their weekly hours reading, which is the Y, to increase because the slope is positive by 0.5 on average. So make sure to do this right here. Notice where it's underlined, we are plugging in the numbers, and I am interpreting the slope coefficient, which is relative to B1, and say to yourself, well, that's for each 1 unit increase, where B0 is for when X is equal to 0. The last one we have right here is the R squared. When it comes to the R squared, we are going to be using the R squared right here, and that's basically 0. Yours probably won't be. Since this is basically 0, I can say about 0%. But I do want to point to one where it's not 0, because it might be better to have an R squared that's not basically 0. Let's go right here to this one. Take a moment and see if you can interpret this R squared. We'll put a little chill music on right here. Could you interpret this R squared properly? 320 was just doing this. It's a good practice for 320 any class. I'm out of coffee. I got a little bit of lunch and I got congested. I don't know why. Could you interpret this R squared right here? It's blank percent of the variation in Y is explained by the variation in X. So blank percent of the variation Y, we'll put it over here on the side. Blank percent of the variation Y is explained by the variation X. I see a lot of people lose points on the test right here because they say it's positive correlation. Or that's a moderate correlation. No, 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 no. This is not correlation. I've got these things highlighted right here so you can see this is not correlation. So how would we interpret this R squared right here? How would we interpret this? Remember, you're going to times by 100. This one's a little better to interpret because we wouldn't say about 0 for this one. This one's some decent variation. How do we interpret this R squared? Oh, Muhammad's in QQ straight enough knowledge. Love it, Muhammad. Plot doesn't think it. Excellent. Muhammad memory right there. Muhammad was 201 a while ago. Muhammad's some points right there. So how do we interpret this R squared? Good practice. So when you get to test, you're like, oh, that's not correlation. That's percent of variation explained in Y from the X variable. So what percent of the variation of the Y variable is explained by the variation in the X? How do we interpret that? Now to make sure. Use this right here. Tiffany, good answer right there, but that would probably be like a half a point out of 3. So use this right here. So use this right here, try it out. And remember for the test then, if it says interpret R squared. So you want to take your R squared, times that by 100, and then you want to plug in your Y variable, whatever the Y is, and you want to plug in your X variable. If there's an underlined portion, you want to take and plug in the values for those spots. So this is where R squared goes. You times by 100 though. And then this is where the value of the Y variable goes. And this is the value where the X variable goes. So how will this look right here? It's good practice. This is where I see people lose points. So that's why I always pause on these things. And I'm like, can you interpret this R squared right here? Because when it gets to the test, a lot of people say it's positive or it's moderate. R squared is the percent of variation in Y explained by the variation in X. So how are we going to interpret this? Very good test question. I expect there to be written portions on this test. And this is where people are going to lose points. But if we know it, we can just be like, oh, that's this. So plug in the numbers. The Y variable over here is height, and the X variable is weight. Right here's where the Y variable is at, and here's where the X variable is at. And then you can check the axis also. So good questions right there. Good questions. Bring the interps back on the screen. So we need to know the Y and the X. So it's really good test practice right here. To make sure when we get to test, we're like, oh, it's this percent of the variation in this is explained by the variation in this. How do we interpret this? A lot of people lose points. A lot of people are going to lose points on this visualization by just saying, like it's positive or it's moderate. But it's the percent of variation in Y explained by the variation in X. It's not correlation because R squared is always a percentage. So it's never going to be negative. R squared is always going to be from 0 to 1 because we're squaring the correlation. So what would it be? Then we'll talk one last concept about this. What would r squared be? Like the interpretation. So we look at what r squared is. There's r squared right there. So we're going to take the r squared. Nice job. Oh, but careful, careful, careful. Wait. Take that answer right there. Make sure to give the context. Make sure to give context. So make sure to put your context in. So you are correct, but make sure to give the context. Anytime you see something underlined, make sure to input. Like if this is underlined right here, we have to input what the y is. That means it's a blank spot for you to input the values. So this right here is a blank spot. I should maybe make that clear. That's underlined. And so we need to put in the y and the x context. Really good test question right here. So make sure to put in the context. Oh, but and do the whole thing. Gotta get the practice in. Here, we're gonna do just a moment longer on this. Gotta get that practice. Gotta be like, okay, 36.12% of the variation in this, I'll say here, 36.125% of the variation in height is explained by the variation in weight. Make sure on the test, make sure to give it full context and to give the full answer like that. You should get full credit. And also for your assignment for the visualizations or for projects, make sure to give the full context. Make sure to input your x's, input your y's, and input the coefficients like the intercept or the coefficient of the slope. Really good practice right here. Now, the last thing to note is that the statistical significance of the model, would it be based on the intercept? So the intercept is a point at when it hits 0, or would the xy relationship be based on the slope? What is the statistical of the significance of the model related to? The intercept, I'll leave this one on screen. Would it be the intercept p-value or the slope p-value? Which of those sounds more important? The slope? Great job, Tiffany. Excellent work right there. Great practice. Would the statistical significance be the slope or would it be the intercept? So changing the intercept looks like this. Changing the slope looks like this. Which of these looks like the xy relationship? The slope, is that the xy relationship or is the intercept? I mean, the intercept is important, but which of these sounds more like how x and y are related to each other? Whether they have a negative relationship or a positive, would that be more related to the slope of the line or the intercept of the line? Which of those more tells us information about how x and y are related to each other? Which of those would be talking about the xy relationship? The slope right there, more points. So when you go down here and look at the coefficient of weight, weight is the x variable. So this is the significance of the slope. Look at this 0.07. That's the same number there. I just rounded it. So this model is statistically significant. I think we have some not statistically significant models up right here. That one is. So this one is less statistically significant. P-value is a little bit higher. We should have one that's not statistically significant. Can we get one that's not statistically significant today? Maybe they're all statistically significant. Let's find one that's not statistically significant. We're going to go here to analyze. Whoop. Fit y by x. We're going to put in how many tattoos someone has. And we're going to tell, that's going to be explained by how much they're on Facebook. Ooh, those outliers might be doing it to us. Yes, we've done it. This is not a statistically significant model. Ditto, good to see you here. Does everyone see why this is not statistically significant? Why is this model not statistically significant? I would say to someone, this model is not statistically significant because the p-value for the slope is what? This model is not statistically significant. Here's the slope coefficient right here. It's a very tiny one. It's down here also. So the slope estimate, B1, which is right here also, it's a positive line, goes up a little bit. The p-value for the coefficient of the slope, because this is the p-value here for the slope, look how it connects in right there, is what, and thus it is not statistically significant. The p-value for the slope is not statistically significant because it is what? I haven't looked at, I'm sorry, I was teaching. I'll look at it after class today. I'll give it a check and I'll tell you if it's good or bad. I haven't looked at it yet. But yeah, is it just the graphics? I could look at it. This one's not less than 0.05 exactly. Let me see here, Tiffany. You know what? I'll do that right here. We'll look at it and I'll tell you via this right now. If you're okay with that, are you okay with that? I'll look right here. I'm not going to look at it on screen, but I'll go back to the main screen here. Let's do that. It's a good review of everything right here. Thank you so much, Tiffany, and sorry for the delay. Let's hop over to the main screen. You're welcome. So let's go and take a quick look at that. All right, so let me go here. Scrolling down to okay. Let's look at the graphs. Okay, I'm gonna look at the graphs. I'm telling you the graph looks good. Yeah, that's got the right graph. Excellent job. Perfect graphs. You don't need the remaining graphs. You only need down to the graph with the second page. So you only need down to the second page. Does that make sense? You only need the one that says, here, I'll show a small picture of it. I'm not going to show the full thing. You only need the start of the second page. Let me go away from the email real quick. And so you only need... Is that me now? So you only need down to... Wrong button. You only need down to this. Yeah, I delete pages 3 and 4, I think. If you see on your second page, you have a graphic that looks like this right here. You only need down to that page, that graphic right there. You only have the first diagnostic residual plot. There you go. And we got some explanations. And we're going to hop in here to the next one. Excellent work. Getting ahead. Excellent job right there. So we got right here. Second question. Can we look over number 9, Macy and Muhammad, with number 9 right here? Excellent work, Macy. Excellent work, Muhammad. Let's take a look at some number 9 for BAS 474. Number 9, clustering assignment, BAS 474. Let's do this. Wrong button. What? Okay. Let's pull up some data right here. Number 9 for BAS 474. We're going to jump down to it. Here we are. So this one, I might not be able to get too much hints for this. I don't want to go into too much detail. So what you need to do for this one, Kroger finds the 5 clustering scheme to be most useful. Characterize the 5 clusterable, meaningful descriptions. It's hard for me to do this one without doing this one. So I might have to pull up some notes right here to look through it. So make sure you have your 5 clusters saved. That's what's most important. And then we're going to use the aggregate function right here. So if I do, I think I have a clustering scheme going right here. Make sure you use, let's say, similar but different work. So we want to go here to the aggregate function. And let's hear. Look for patterns, a bit above average, a bit below, tell story. In tandem to interpret the output on 7. Left arrow into Kroger into Hierarchy cluster, and then add the cluster identities in the 5 clusters. Then use the aggregate to look at the median value for each category, round to the nearest dollar. Okay. So we need to go right here. We already have a cluster scheme going. And our cluster scheme was in the cluster scaled with IDs. So we already have these cluster IDs right here. And so the cluster scaled with IDs are in, I called it like K3. So you need to make sure you have your cluster. Let's throw out some points. Madeline, good to see you here. Fraction scaled with IDs. Here's the IDs for K3. So these are the cluster IDs. We obtained these earlier in office hours by doing the code. We did a bit of that one. I'm not going to do the full this one. But we obtained these cluster IDs right here. And so now I'm going to take these cluster IDs, which might be better obtained by using... So I'm going to use these cluster IDs to talk about it. I'm going to take these cluster IDs right here. I'm going to go to the Kroger data. And I'm going to store into the Kroger data K3. And now I have the cluster data on the Kroger data. I probably want to do it down here, where it makes more sense to store the Kroger cluster IDs. And so that is going to store a variable cluster 3 IDs onto the end of the Kroger data frame, so we can see this person belongs to the 3rd cluster. And this is way back in time when we were doing some dendrograms. Do we still have a dendrogram saved to look at? We were making dendrograms earlier today, and here's where we're getting our cut on our dendrogram. Oh my gosh. So you can see right here. You gonna change? There we go. Here's our cut on our dendrogram to cut them into 4 clusters. We were cutting into 3 clusters, which is going to be a little bit higher up, around 48 or so. So if you look at where this cuts right here, somewhere around 48 or 49 is going to cut it into 3 clusters. Think about a samurai sword going across this and dropping the chandeliers down. So this is going to fall here, fall here, fall here, and we're going to get 3 clusters. So that is how we're getting these clusters. And now we want to go here and look at the aggregate. Now, the way aggregate works is it runs a function on multiple instances of y based on some sort of function across x's. It aggregates across different x's. So we want to go right here and use all the y's, which is dot. And we're doing tilde, which is the formula format. And I'm going to say K3. I think my K is capitalized. So this is saying analyze all the y's based on the x variable K3. So that says I want to look at all the y's, every single product people bought, based on all the clusters are going to separate them out. And now we need to go to the data, y tilde x comma data equals. Kroger because they're inside the Kroger data frame. And then last but not least, I'll probably get this one wrong. We need a function, I don't want to be function. And the function is going to be, it says look at the, say, mean or median. Look at the median. It's going to exclude outliers right there, and it did work. Sometimes it's fun, sometimes it's function. That doesn't work. Yep. I finally learned it's capitalized, and you don't include the function part of it. That'll make a mistake. Now, this is a K3 clustering scheme, and I'm only going to point out a little bit here so I don't do too much. This is analyzing all the variation. I have to disappear in a second. Really? You can do that to me now, R. So here we are on the screen, and what do you notice? Something jumps out to me immediately. Your clusters might look different, but if I'm going to talk about cluster 3 right now, what would I say about cluster 3? There's something about cluster 3 that jumps out to me immediately about cluster 3. Cluster 3 jumps out to me immediately. And we can look at the z-scores. We can look at different things here. Cluster 3 has an immediate characteristic that jumps out to me. So what do you notice about cluster 3? These are a group of different individuals. We have 3 groups. Just think about you have your A group, your B group, your C group. Pet, let me look at pet. Pet for cluster 3. Baby. That's jumping out at me right there. These people have babies. To some degree. That's jumping out to me right here. So these are my baby people who probably own pets. They spend a lot on others, but really they're buying some baby stuff. How do you determine which cluster are useful or different from the one another? I have my z-scores for the clusters in 4B, but don't know how to analyze them well. So when you want to look to see if these clusters are useful, this cluster right here, don't want to quite say answers, but there seems to be some useful information right here because these people are buying baby products. Would it make sense to go to cluster 1 and give them advertisements for baby products? Yes or no? So think about how this is useful to say, we should be marketing clusters. We should be marketing baby products to cluster 3. Would we market baby products to cluster 1? We're in the marketing department and someone says, we should send them baby coupons because they're not buying anything. You'd be like, well, they probably don't have babies because they'd be spending money on it. But these people down here are spending a good bit of their income. If you look at the totals, the baby column is actually one of the highest for them. These people are a little bit higher in meat. Do we have the scaled data set? I'm going to run this on the scaled data. What is it? Scaled. Yours is going to be a little bit different. What is it called? Fraction scaled. So we could look at some fraction scaled with ID. So here we are looking at a different clustering scheme. And yeah, you can see it. They pop right here too. This is definitely the baby cluster again. This is a different, yours work's going to be once again, similar but different work. Want to point that out. But still, these people, why are they, just saying, I want you to think, why are these 2 z-scores the same right here? These are z-scores now, and why are these 2 z-scores the same for clusters 1 and 2? Look at the original data, and then look at the z-scores and be like, okay, well, it's probably because of this. Because clusters 1 and 2 are doing what? Clusters 1 and 2 are not doing what? And thus their z-scores are going to be what? Clusters 1 and 2 are not doing what? And then we look at their z-scores. They're below average. I mean, I'm below average in what people buy for baby products because I don't have babies. So they basically spend nothing on babies. Exactly. That is the median. So if there was some sort of outlier or something, this is the median value. And the mean right here, the z-score is going to tell us in terms of how far things are away from the mean. So this group right here has an observation, and they might just all spend 0 on babies. But these are definitely the individuals with babies. So if this was my cluster 3, I'd be like, definitely the baby people. Right here, looking across, what else do I see? I'm not seeing anything really high on the z-scores, and I don't know if these are the exact same clusters, but I'm going to assume they are. They really are just high in baby stuff. They do like drinks. You see these are different clusters. So kind of not a good idea to look at that. It did cluster them differently with the fraction scaled. But these are the baby people. They're buying grain and meat a little bit higher. And they might call it, they might like to stock up on items. So they might be like larger family people, possibly families. Like what we're seeing right here, now for the 4th and 5th, yes. Just change the clustering scheme you're using, and then you can look at different clustering schemes and just see what information it brings. I obviously don't want to do the whole thing, but going through here, looking at the z-scores, look at the z-scores for them too to kind of see if things jump out to you. I mean, this one right here is jumping. It's almost at a z-score of 2. If it was more extreme, like if you did something crazy right here, which don't do this. If you did something crazy right here, like made like 8 clusters, and that's scaled now, and then these are z-scores still, right? Because it's scaled. And then you go down here to a K clustering scheme of K8. This is a horrible idea. But with 8 clusters, would we see anything that pops out? And I'm looking across. That kind of pops. These people don't like to cook, but they do like drinks. They're buying their soda. And they, oh no, this is my junk food people. They're just buying soda. Soda. Maybe it's good drinks. I don't know if it's good or they're not buying alcohol though. They don't have babies. Which cluster is this? Cluster 5? Yeah, cluster 5 just likes to buy drinks. Hey, Cora, good to see you here. So does that make sense? And so cluster 5 really just likes to buy drinks. And unfortunately, that might be one of my only key characteristics. Oh, look at this. Cluster 2 is my pet owners. So that's something that jumps out to me right there. And I could start to use this. Hint, Macy. If I want to use this, this is going to maybe help out. But I have gotten for question 6. I might have done that earlier. I'll still check. But does this make sense, everyone right here with the clustering, where this jumps out to me? These are my pet owners. There is variation among the other z-scores. These people are below average. But this jump right here for that pet owner one, like, these are my pet owners. Like, cluster 2 is where I'm going to be marketing my pet products. I'm not saying to use an 8 clustering scheme. We'd have to see if this helps. But that is my segment of market that is people I'm going to market pet products to. Over here, I've got my people. If we come out with a new drink in our store, like there's like a new Gatorade or something, I'm probably going to market it to cluster 5 because they're my people who will buy my drink products. So I could probably send them more coupons for drinks. Maybe try to find some products that branch. Here's my baby cluster right here. Cluster 4 is my, there you go, they like to drink. So cluster 4 is my like to drink cluster. And I could go here and start to make ideas of my marketing scheme. That kind of branches into Macy's question right there. On number 7, and we might have done it earlier, check number 7 or email me or Discord me to see if you're getting it. For our question, will we be using yes? Make sure to use what it says right here. So left arrow Kroger into this. So you're just making a copy of it right here with the clusters on it. So you're just creating a copy. Does that make sense right there, Mohammed? So you're copying Kroger into Kroger with the hierarchical clustering attached. I'm not always the best about keeping my data nice and neat, but this is going to store into Kroger hierarchical clustering to give the cluster IDs on it. So we can kind of keep our data sets separate. We have the original data, and then the point of this data frame right here is we're going to add the cluster IDs to the end of it. So then add the cluster IDs for your 5 clustering scheme. Yes, send it to me. Yeah, send me your file. Yep, and send me a picture of what you're getting. Send me a file and a picture, because sometimes I rerun it and sometimes it works. Excellent questions. We'll circle back if we got more questions. So the next question was, we did visualization 5. So Tiffany and Harrison. So we're going to do some questions 5 and 6 on the homework. Let's hop over here to the main screen. Let's do this. Excellent work, everybody. I know it is almost fall break. We're playing the Nathan Drake collection on PS5, PS4 game. But man, Nathan Drake games are awesome. We're almost through the second, and then we have the 3 and 4, and then the kind of spin-off story. So really excited about that. Anyone have any PlayStation suggestions for games? I missed out on all PS4. Number 6, so I need help on 5 now. You got number 6. That's awesome. Was that I did extend the deadline today in class? Yep. Wait. Yes, for 474, right? Sorry. A lot of different classes. So I did extend it. Yep. In class today. Woo! It's kind of warm in the apartment. Hopefully, congestion today? No! I'm doing fine. Everything's fine. Should have made that. Let's go here. Oh, we're doing the homework. Chapter 7, homework. go here and do some chapter 7 homework. Oh, this is the big one. Let's do the big one. Good practice right here. Hey, Thacker, good to see you here. Good to see you, Thacker. I haven't seen you in a while. Yeah, Thacker, 50 points for Thacker showing up. Thacker, this goes out to you right here. New effects this semester. Got to use them when we can. Let's hop over here and do some chapter 7, the SAT question. One of the hardest questions. Let's do it. So this is the SAT question. It's a pretty tough one, and we need to use the regression solver for it. You don't need to use it, but it's going to make your life a lot easier. So the regression solver can be found. Let me go grab you where it's at, and it's going to be under 2 seconds here, everybody. We're going to go over here to the Stat 201 course on Canvas. And in your Stat 201 course, you want to go over here to the modules section. And under the modules, always a pleasure to see you too, Thacker. Thank you so much. And under the modules, you will see the Regression Solver Pro. Is the question report... Exactly. That's what we were talking about at the very end of that. Yep. Tiffany, great work. We were doing it earlier, Campbell. Check it out. We did a whole thing on visualization 5 at the very start of this. So check out the start of the video. A lot of Viz 5 right there. So check it out. And so, nope, not the same thing as R squared. Nope. It's the p-value. So good question right there. Nope. Different thing. So this is the Regression Solver Pro. Make sure to download it. It's going to make your life a lot easier. And these are questions we would not ask on the test. So we're not going to ask you to solve using these values like the correlation, the standard deviation of y, the standard deviation of x, the mean of x, and the mean of y. We're not going to have you calculate things on the test. I don't see regression solver. Go to modules. We'll double check, make sure you got it. So you want to go to the modules section. So go here to modules. Question about the cluster identities. Oh, go ahead and ask Thacker. Go ahead and ask. I'll try to figure it out. So go here to modules, and under modules, you want to go down to chapter 7, and it's right here. So I might have to answer via Discord, or I might do it next here if it's a big question. So there it is right there. John, do you see it? How's it looking? I always wonder, is that Kermit the Frog doing what? Try to figure out what Kermit the Frog's doing. No, that's a meme, isn't it? It's a meme frog, right? Isn't it not? I've seen it. It's a long time ago. I feel like that's like a 2010 meme. I forget. There's so many things. It looks like Kermit, though. Forget these things. Let's see right here. We hopefully have it. And that's going to make this question a good bit awesome. Got it. Good to go. Let's check it out. Hopping in here to this question. So this question is going to use someone's verbal score to explain their math score. Now, this is probably me up here. What was Brian's verbal score about? So use this right here. And tell me about Brian's verbal score. Brian's verbal score is probably pretty close to a what? Probably me right there. Pretty much. That's pretty much it, Thacker. Yep. We're going to look at the patterns across the data and then create cluster IDs that group together the most similar things based on their distances, or like the dendrogram will be doing distances, or we can use the k-means algorithm to try to figure out the best cluster centers that reduce the error between the clusters, the within cluster sums of squares. Yep, that's the right track right there. The k-means reduces the within cluster sums of squares, and the dendrogram uses distance matrices to group together things that are most like each other. Excellent work. What was Brian's verbal score and what was Brian's math score about? Brian does not look to fit this model so well, because this model right here is going to be a y hat, which is a predicted y value, equals to b0. That's going to be the slope of the line for each 1 unit increase in x. That's not a unit, but we're pretending. Plus b1. Oh, there's b1. Sorry about that. Reversed it. And b0 is this right here. So that's b0. And b1 is the 1 unit increase. And b0 is when x is equal to 0, which doesn't actually make sense for this. So we can't talk about the b0 right here, because you can't make a 0 on the verbal score. You can only make as low as 200. That's how low the SAT goes on a section. So we understand what we are seeing. We're seeing a regression line. You're welcome, Thacker. Excellent work. Thank you so much, Thacker. Some green random buttons. So the association between math scores is moderately linear and positive. Students with high math scores typically score high on their math scores. So good stuff right here. We're seeing a positive relationship, and it's moderate, it's linear, all that good stuff. We do have a bit of an outlier. That outlier right here is somebody who made a 250 on verbal, about right here, 250, and an 800 on the math. So bit of an outlier right there. So that would fail our QQ straight enough. No outliers. So we've got a violation of that condition. Plot doesn't thicken looks pretty good. Remember those conditions. QQ straight enough. No outliers. Plot doesn't thicken. Next question going right here is the correlation is 0.62. How do we get r squared from correlation? How do we take correlation and get r squared from it? How do we take correlation and get r squared? So how do we get correlation and get r squared right here, which is the percent of variation in y explained by the variation in x. I can't state this enough that correlation and r squared are different things. On the test, people lose points because they just say it's moderate correlation. And like, no, this is r, we're doing r squared. To get r squared, correlation is r, so this says correlation is 0.62. So let's go here and go 0.62 times 0.62, and now we've obtained r squared, which means 38.44% of the variation in somebody's math score is explained by the variation in their verbal score. So also about 38.4% of the variation in math score is explained by the variation. This is perfect right there. And let's see what the other one says. Students who score 1 standard deviation above are expected to score standard deviation above. This is the positive or negative relationship right here. So don't worry about the standard deviations. It's just saying that there's a negative relationship, which there's not, or there's a positive relationship, which there is. And then over here is a excellent interpretation of r squared. Blank percent of the variation in y is explained by the variation in x. So more than just clicking answers right here, it's knowing why this is the answer. It's the percent of variation in y explained by the variation in x. Excellent job, my Pearson. Great answer right there. Going forward, we get to some of the more difficult questions like the regression equation. Now, this is where it gets pretty tough and a lot of people make errors. We're going to bring this over here and bring this over here and have it showing on the same screen at the same time. So what we need to do is we need to use the regression solver found on Canvas under modules. If you just got to this portion of the question, I'll show you where it's at right here. 2 seconds. Let's make this look nice and pretty right here. And there we go. Getting the problem nice and neat because we're going to need an extra thing. I don't think we're going to be able to see the thing we need. Got to make it all perfect. There we go. Oh, really? Well, that's good. And if you enter in a number wrong, the problem says no. Excellent. That's all the information we need. Okay. So we're going to use the regression solver here where we get the summary statistics. And an important thing to know that this regression solver is found under Canvas. And where do I have the Canvas? Here it is. This is under the modules. Make sure to be under modules. And then go down to Chapter 7, and you will see Regression Solver Pro 3.2. I've been updating it as the semester has been going on, and the reason we use this is because we would not ask a question like this on the test. It's just a bunch of mathematical work that are equations we don't ask you to use. So this question is excellent besides for this part right here, but it's essential to getting the equation. If you notice right here, we have the correlation, which is R. That's the notation for correlation. So that's 0.62 is the correlation. We have here the verbal scores had an average of this. Remember, verbal is x. So let's see, that's the average for the verbal, which is mean of x, which is x bar, 4, 6, 3.3. And then the standard deviation for x right here is 170.6. Make sure to enter in all the decimals. The math had an average of 521.4. So that's the mean of the y variable, because remember, math is the y variable. And then the math had a standard deviation of 146.6. And here we are with the intercept. So let's just put the intercept right here. The intercept, which is B0, good practice on our notation right there, is the following value. And the slope is 0.533. Round to 3 decimals. Have we done it? We have. How's that looking right there, John? I'm going to pause on this. Does it make sense how I got all of this? How does it make sense how, be very careful, knowing that verbal is your x. So if you see standard deviation of x, that's the standard deviation of the verbal. If you see the mean of x, that's the mean of verbal. And we know verbal is the x because it's on the x-axis explaining math. Remember, x means explain. Y means why do people have a certain math score, the response. So how are we looking, John, on this? I'm going to pause right here since you're the one who asked. I want to make sure you're doing all right on this question. How's it looking? Sure. Awesome. Great work, John. Once again, we wouldn't ask test questions like this, but now we would ask test questions like this. I wish that gave it in context. It just can't give it in context or it would give you the number. So remember, we have our interpretations. Let's make this full screen here. Since we have the equation, let's try doing it. The interpretations are for each 1 unit increase in X, so for each 1 unit increase in verbal score, we would expect somebody's math score to increase by 0.533 on average. For each additional point in verbal, the model predicts an increase in their math score. They don't go into too much detail. I wish they did. Now we have the intercept right here. Well, the intercept would be someone with a verbal score of 0 would have a math score. We would predict them to have a math score of 274, but that's not logical because you can't have a verbal score of 0. Someone who makes a 764, so what are we going to do right here? If someone made a 764, what could we do with this value of X right here? So just explain to me, if someone made a 764 on verbal, because verbal's X, so what could we do right here and solve out to see their predicted math score? And it says expected, which means predicted. So what could we do right here to get somebody's predicted math score? It's going to move all around like crazy. What can we do right here to get somebody's predicted math score? To get someone's predicted math score, we have to use the value of X. So what do you think I should do right here to solve to get someone's predicted math score? Just plug it in. Yeah, just go right here and just go 764. Good. Don't want to put in the wrong number. Multiply that. And here's a good thing you may not know, is my Regression Solver Pro actually has the ability to solve this by typing in 764 right here. And you get this right here. Now, it should accept this. Round to the nearest whole number. Ooh, Ma Pearson, you better not be mean today. Round up to the nearest whole number. Check answer, says well done. So it would round up. This carries more decimals. The Regression Solver Pro, it's got to be Pro, carries with it more decimals. Now, this one's a tough one. This is the one people get stuck on. All sad right now. Because on this one, it says every year someone gets a perfect 1600. So for someone to get a perfect 1600, tell me this. If you get a perfect 1600, what would your math score be? Like your actual value of math. So let's put here math. And that is going to be, if you got a perfect 1600, your math score would be what? With a perfect 1600, your math score, which is the Y value, would be equal to what? If you got a perfect 1600, your math score, which is your Y value, that's what you actually got. So that's what Y means, would be what? It'd be 800. Yeah, great job. I'll answer the next one. John, so quick right there. Earning 100 points. Keep it up. That means your verbal score also, which is your value of X, is going to be equal to 800 also. Because how do you know this? Well, if you get 1600, you have to get two 800s. That's the way to get a perfect 1600, is to have 800 on both. So it takes a little bit of deducing right there. Okay, you get a perfect score, 800 on both sections. So this would be their score overall is 1600. So then right here, we have to say, well, what is their predicted math score? So to get their predicted math score, we have to take our solver and we plug in the number. Now, this is the easy way of doing it. This will get us their predicted math score. But what are we doing? All we are doing right here, and I'll show it, is we are taking this equation. Let's grab it. Oh, where's our equation? To get their predicted math score, which is Y hat. So let's write math, and we'll put a little predicted over it, which means this is the predicted Y. And that is going to equal to this right here. This is their predicted math score. So all we're going to do is go to this value of X and input their actual value of X, like what they got. They got an 800, so we're just going to put here times 800. That is what the regression solver is doing when it's predicting the Y value. So their predicted math score is like 700 we saw. Let's go here and plug in 800. This is their verbal score. They got a 800 on their verbal. And then we times that by the slope of the line. and then we add that to the intercept, and we're just solving out an equation right here to find out their predicted math value, because that's what the line gives us. And it's what the regression solver gives us. So this is what we predict they will make. And think about this. What we should see over here, if we look at the equation or the line, is you should see 800, 1600. This is below. So tell me, I just want you to estimate mathematically. Don't carry all the numbers. What do you think the residual is? If this is the predicted amount right here, which is 700.9, and this is what they actually made. So the formula for residual is residual equals someone's actual score minus their predicted, which is E equals Y minus Y hat. So what would we get right here if we do someone's residual is their actual minus their predicted? And this was, let me carry the decimals, 700,964. I love that, John. That's worth 100 points. Excellent work right there. It's about 100, and it's positive because, remember, they're above the line. So since they're above the line, it's going to be positive. Anything below the line would have a negative residual. So it's going to be 99.036. My zeros look like sixes. Let's fix that so no one gets confused there. And how are we getting this? It is being obtained by doing the actually scored. Oops, wrong button. They actually scored an 800 minus the predicted score, and we are showing this right here. Let me highlight it to make it look a little clearer. This is their predicted value right here, and this is the predicted value. And then the actual score that they made on the math is right here. This is what they actually made. And so here's their actual score right here. All of these just represent the same thing, just in notation or with the actual numbers down here. And we know they actually made an 800 once again because they made a 1600, and the only way to get that is to make an 800. So on both sections. So that gets us their predicted. Once we have their actual and their predicted, we can find out how much we missed by. And this should be a distance of about 999. And looking at it visually right here, it should look like that. You should ask yourself, if I'm looking at this person on the scale right here, do we miss by about 100? And are they positive? Well, they're above the line. That means they're positive. Anything above the line is positive. Anything below the line is negative. And this probably would go over here and hit about 700 for the predicted for the line. And then the actual right here has to be 800. And that distance right there is the 100 residual. Does that make sense that this is how we're calculating the residual? And you can kind of view it right here visually to say, okay, they're about 100 above the line. Now, we did it more precisely. And we found out that their exact residual, make sure to carry your decimals, is going to be 99.036. And tell me I carried all the decimals. Come on, Ma Pearson. I carried all those decimals today, didn't I? Oh, we did. I was so scared. We got it. John, this is one of the hardest questions, I would say. It covers a lot of concepts. It pretty much covers the whole chapter. Really good question. So if you can conquer this question and do it well and understand the concepts behind it and understand where residuals are coming from, understanding how the line makes predictions, you're doing excellent. John, how'd you do on this right here? Good stuff right here, John. Excellent work. I hope so. We got time for more questions. Let's hop back here to the main screen. I got it now. You're welcome, John. Good job. Good stuff. Nice. Got my timer on the screen. What was the next question on the screen? Can we do some more quiz 7? Yeah, let's talk back to quiz 7. Quiz 7 after this. Madeline, great questions right here. Quiz 7. So excellent work, John, right there. That is a tough one. One of the toughest ones, one of the longest problems. A lot of good theory, a lot of good practice on it. And those are the ones you want to conquer. To be like, okay, I can do some of the harder questions. Then the easier stuff, like if a residual is positive or negative, what would it mean? Let's do like 4 or 5 of these questions. Okay. Let's see right here. I'll drop to some true false at the end. Is there no true false? True false is fun. Oh, we didn't do the burger one earlier today. We've done the hard water. Let's do the burger one. This is the burger question right here. And so Stat 201, Chapter 7, burger question. Let's do it. So we got some data to start. We love data. I say that sarcastically, but I'm serious. Data's awesome. I like data. So I like turtles too. So here we go. We've got fat for a burger and how many calories a burger has. And right now, there's a bit of an issue. It says the data below shows the fat and calories in fast food burger. A model was created to estimate the number of calories. That makes that the Y, because that's what we're trying to explain in a burger when the fat content is known. So if we know the fat, we can estimate the calories. Explain why you cannot use that model to estimate the fat content in a burger with 600 calories. So the equation's written wrong. They're switching the Y and the X right here. They're saying let's estimate fat now with calories, which we're going to do in a moment. Someone says, oh, I know the calories in this burger. Let me predict the fat. Well, we can do that. We have to make a new model. So the regression model was made for predicting calories from fat. And right here, you can see that. Good to go on that. Using an appropriate model, estimate the fat. And now we actually need to make a model right here. So let's go ahead and make a model on how to do this. So the model is going to need the data. Copy to clipboard. And when we copy the clipboard, you'll notice it does have column names. I'm going to hit Control-C or Command-C on a Mac. A few times. Helps. And then we hit Done right here, and we've copied the data to the clipboard. You're going to go down here to Jump, and inside of Jump Anywhere, you're going to go to File, New, Data Table. Notice how we're going to File, New Data Table. We're going to start a new data table. Anywhere in Jump, just go to the top and go to File, New Data Table, or you can hit Control-N. That's the quick key to do it. And that'll open a new data table. Don't click inside of it. Just wait. You can maximize the screen, helps out a little bit. See what's going on. Now remember, it did have column names, so when you paste with column names. That's huge. So when we paste with column names right here, what we want to see is that these are blue. That means they're quantitative. Take a look how what happens when you don't paste with column names is that they're red, and that's saying it's a categorical variable. Not good. Not good. We don't want them to be categorical variables. The column name went into the first observation, and that's not what we want. We want the column name to go into the columns. That's the column name. Once again, do not try to fix this. Immediately close out of this, open up a new worksheet, and paste with column names. I was using the quick keys there, but you can find them up here. File, New, Data Table, and also Edit, Paste with column names. Make sure to do it slowly. We did slowly to start. Now that we have the data inside of Jump, we can actually analyze it. We want to do a bivariate analysis right here, which is analyze fit Y by X. So analyze fit Y by X is going to predict some Y variable based on some X variables. So we're saying, let's understand the variation in this Y based on some X variable. So here we are. And now we're going to choose the Y variable of interest, which was fat. So that is what we want to understand. Why do burgers have fat in them? Just think of asking it that way. Why is there fat in burgers? I want to understand that. And then the X is going to be the explanatory variable. Good way to remember it. Explanatory. Other words for it are the predictor, the independent variable. I just like to call it explanatory. It explains things. Hit OK, and you've got your model, but this is a scatter plot. Pretty interesting. Looks pretty good. Like you can see the line's going to go through it. No real outliers here. No plot thickening. Q, straight enough. No outliers. Plot doesn't thicken. If you said it, you got around 100 points if you said it. Someone said it. And so we are going to fit a line to this. By fitting a line, it's going to do the regression equation for us. You can see the intercept's probably going to be, oh, the intercept's really far out. It's going around 0, is it? Oh, it's close. It is around 0. The intercept is actually off the screen. You can't even see it. You don't usually do this. The model doesn't always show you because it's outside the model. It's an extrapolation of the model to go to the intercept. So the intercept is actually down here. Let's make the model show. But usually you don't go and do this. You're usually interested in observing points in this area. And we can actually go back to that, I think, if we... there we go. Look at that. Oh, my model's all messed up. Watch this. Let's go back. Let's redo it. I don't like the way the model looks. Analyze, fit Y by X, predict fat from calories, click OK, got the model, fit the line, make sure we're not clicked on anything, we're good to go, got the pointer tool, awesome. We're back to square one. So an important thing to know right here, and we make sure we understand this output right here, is that we have a few places where we see the intercept. I'm going to draw on this output right here to make sure you see all the important things for 201, and this also kind of counts for 320. Don't like that screenshot. So an important stuff with this output is you will see this on the test. I'd be shocked if you didn't. So when we read this output, who in the chat can tell me what is the intercept? What is the intercept right here? Just tell me what's the value of the intercept. Don't worry, that's not interpret the intercept, which is a different question. What is the value of the intercept? What is the value of the intercept? So if you can take a moment and tell me, what is the value of the intercept? Just what is the intercept? That's an important thing to first know is like, what is the intercept? Now, the intercept is B0. So what is the intercept? I don't know how many people are watching. Nice job, Kayla, right there. Excellent practice. Yeah, Kayla, you got it. Some points, but negative. Make sure to put the negative. So it is negative. Kayla, thank you so much. Excellent work. Kayla, if you have questions, we can do your question next here. If you have questions, that is B0 right there. And then B1 is the slope. And Kayla, good to see you here. Good practice. And that's B1 right there. Great job, HTT. Good practice. Another 100 points. Thank you everyone for following along, even if you're in the upper level classes. It's good practice to make sure you know how to read this output. It's the same thing inside of R. Like literally, I think I've got a regression model inside of R, and R is going to give you the same output. If I do a summary on a regression model, here, oh, I don't have a regression model in there right now. Where's my regression models? Here it is. There's a regression model. Here's the intercept. Here's the slope. So we have the same output. Look at this output right here. Look at me. Now look at you. Look at me. Now look at you. Same output. This is where the estimate of the slope is right here. This is where the estimate of the intercept is right here. Down here's the estimate of the intercept. Here's where your model is written out with the intercept value and the slope value, the intercept value and the slope value right there. Another important thing, Macy, you got it. Next question, we'll do it. I had to get my illustrator. Awesome, good stuff right there. Hope the illustrator's doing well and everything. Another important thing we can see right here is we have the p-value of the model, and this is the statistical significance of the model itself, telling us that this line is statistically significant. That's unlikely by random chance. So we do think that there is a slope, not that it's a flat line. The statistical significance is noted by the p-value of the slope. The intercept doesn't matter. Rock, what do you think about that intercept?
It doesn't matter.
The p-value doesn't matter because the intercept is just a spot. We want to know if there is an XY relationship, which is the slope. If the intercept is 0, who cares? If the slope is 0, then there's no XY relationship. If the slope is not 0, or we have good evidence the slope is not 0 with this p-value, then there is evidence of a relationship. So this is strong statistical significance and strong evidence of a relationship between the calories in a burger having a relationship with the fat in the burger, that knowing calories would tell you information about fat. Knowing calories actually tells you 95.37% of the variation in fat. So 95.37% of the variation in fat is explained by the variation in calories. So good practice on here on the R squared. And frankly, this was like a mini lecture right here. Find the clusters that are the same between 3 and 4. Go back and look at that a little bit more here. So, yep. And so right here, let's take a look at our question. We got the output up. And was predicted. See, that's what happens when I make a mistake. Sometimes I click a button and it clicks away. We need to put in the equation, which we do have the equation. We just need to know those components. I'm just going to take and copy this number. Don't forget the negative. You lose points. That's not a rounding issue. That's a, that's you lose points on the test for that. Oh my gosh. Don't have that happen to you. Forgetting the negative is a true error. It's one of those errors you don't want to have, but it happens. Missing those negatives, problems right there. Round right there, be very careful. The fat content of a burger was 600 calories, and now we're going to plug in calories right here to the equation, and we're going to plug 600 in. Justin, good to see you. We're going to do some 474 next, so feel free to ask any question you want. We're going to plug in these numbers, and we're going to hope we carried everything properly. And so then we're going to subtract from this 14.351. Double check your numbers. Ooh, this is where the mistakes are going to happen. This is such a close round. Such a close round. Ma Pearson, you better not. You behave, Ma Pearson. That was a close round. So what's interesting is we could have used jump to solve this. And I would not suggest, because it did work on my Pearson, you can actually save the predicteds. And then you can go back here into your file and you can actually put in a value of calories, and it'll give you the predicted value of, that's predicted fat, 51.5. Wait, it said 600, did it? I think it said 600, right? How many was that? 600. You see it's carrying more decimals. So probably don't use jump. Probably don't use jump. Oh, it accepted it. Hey, that's awesome. I don't know. It accepted. You see, the thing is probably not going to accept this, though. Oh, it is accepting that? And just going to accept any old answer? Really? Just Maybe it's accepting that one because it's close enough to the... Maybe it has a point... See, there it's not accepting it. So it has actually the two answers in there. It has a plus or minus on the two answers of it looks like 0.1. Oh, it didn't accept that. That's interesting. Well, I'm glad we got it either way. If you think the question's not being fair to you, tell me. It doesn't like that. We got it to accept 35.1 and 35. It accepted 35, which is interesting. Did it accept 35.4? Or... It's weird. You got to round it to that one decimal. But I think because if you don't round your numbers with the equation, but just plug in the number here, it should do it correctly. I just plugged in 600 right there. That's not how I obtained this answer. That answer was obtained from jump. I obtained this answer by plugging in the number, or I used a jump method of solving, which I'm hesitant towards having you use. I just don't know if it consistently gets the right answer. If you get it wrong for some reason and you do this, let me know. But this is how I got this answer. So to take a previous cluster and divide it. Exactly. Oh, great job right there. I can tell when the cluster... Oh, yeah. Yeah, so split into two. Here, we'll look at that real quick right here. Let me bring up this. Let's go back to that. So good that was the burger question. A little chill. Old-timey music. I don't want that stuff. Yeah, our old-timey music. We'll listen to 80s music. Gotta look for some new music. Get some new music on here. I've got sound effects. I never use them. Gotta remember that's that. That's such a dad thing to do. You're like, I never use my sound effects. Get copyright claimed on some... God, I put so many sound effects on here. Whole thing of sound effects. Never use them. Okay. Excited. Don't have them queued in my brain. Stat to One show needs to go on. Needs to have more fun. Snake Jazz. Oh, Snake Jazz. Oh, I know. That was some good stuff. That was from season 4, right? Or is that season 5 this season, Snake Jazz? Some Rick and Morty right there. I like human music. Human music is my favorite. Boop, 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 boop. Oh, human music. That's, what's his name who says that? Patton Oswalt? Who's like, and now, human music. Season 1 and 2 Rick and Morty were great. Season 1, 2 and Rick and Morty was amazing. Season 3 was good. Season 4 was okay. Season 5 has been pretty great again. Oh, thank you so much. I appreciate that. Yep, it was yesterday. I got the piano over there on the side now. Maybe, who knows? Maybe we'll end with a little piano music again here. Which I'll put with some clustering. Thank you so much. I appreciate that, Kayla. I was like, what the heck? We'll just play it at the end of class right here. Have some fun. That's what we do here. We have fun. What's this button say? Oh, that's that. Yeah. I'll work on my sound effects. Let's hop over here and do some splitting clusters up. Let's check it out. Wrong button. So with the splitting up of clusters, so we're looking at the hierarchical clustering, and we do have some clusters right here. So let's talk about splitting of clusters for question number 8. So we're talking about splitting clusters for question 8. If we make a table of our clusters, we can go right here and we could actually use the cut tree. And if you look at this, you can see, maybe we'll see something like this. Mine might be different. Yeah, you can see it. Mine might be different than yours. Kill me, Kayla. Kill me. So where are the clusters being split up right here? So what happened with the cluster IDs right here? Can you explain what happened? I'll give you hints. We'll start this off right here. Cluster ID 2 remained the same. So going from a 3 cluster scheme to 4 cluster scheme. What do we see right here? What else do we notice? What else do we notice? 1 split into 1 and 3. And you'll notice right there, you can check this mathematically. If you go right here and take 1 and 3, and this is what we get with dendrograms, is it's going to split apart, and that's cluster 1. So cluster ID 1 splits into cluster 1 and 3. And then original cluster 3 became... Because there's no truth to this. Does that make sense right here? This is good practice right here to see what's going on. And this goes from the dendrogram right here. You might even be able to see this. If this is, I think this is still the same dendrogram. I can't even speak today. Yeah, you can see it right here. Here's cluster 3 clusters, and here's 4 clusters. So you can see the 2 clusters remaining the same, and then this one gets split apart. If you go from 3 to 4, it's splitting this apart right here. Does that visual? And look at this. This is your biggest cluster, which had 13,229 observations in it. And then this is going to be the 983 clusters are going to be this one. And then the 382 clusters are going to be this one. And then that's why that becomes cluster 2, because it's just assigning the cluster IDs. That makes sense. I just hadn't even thought about it that in depth. This becomes cluster 2 because going across, this is cluster 1 now, cluster 2. This becomes cluster 3 because, is this correct? No, cluster 2 is, yeah, it's not assigning it that way. Is it using the aggregate? It might be using the aggregate. Oh, well, the aggregate is, this is going to show you how things are split apart. So you might be using aggregate to look at the different groups right here. But the table right here, just make sure you're making tables of it, because you can use what you've saved. But so I might not be doing it the exact way the problem says to do it, but whatever cluster, this might be the clustering scheme that you guys have. I always try to do similar, but maybe a little bit different. Does that make sense, Justin? But visually, how can we get the z-scores for the clusters in 9? I was just trying to, but I keep getting the values without being transferred to z-scores. You have to have it from the start. You have to be using the scaled data. So make sure you have like Kroger scaled. We made Kroger scaled way earlier on. Kroger scaled. Make sure you have your Kroger scaled data, which I didn't make this time around. So you need to have your Kroger scaled data. And then with the Kroger scaled data, you can get the z-scores for it. So make sure you have from earlier on the Kroger scaled data. The Kroger scaled data will let you investigate z-scores to see if there's any major differences between the z-scores. And then we also want to look at the actual values to see like, okay, well, these are the z-scores and these are the actual values. Does that make sense, Mohammed, right there? Good questions. Got time for probably one more or so. And how are people doing on the splitting of clusters into multiple groups? Does everyone understand what the end start is doing and what the... I'll do a section on that. Let's hop over and do a section on that. Does everyone understand what end start is doing in MaxItter? Conceptually for the test, I think this is where people make mistakes. Conceptual portions of the test are definitely like some of the harder portions and understand what's going on. Got the cluster. Nice job right there. Awesome work. Macy, great job. And Mohammed, excellent work. 100 points right there. Thank you everyone for all these questions. Hey, Brian, I'm visualizing 5 must 21 if it's a negative value for the... You can. And then does that make sense? We always want to ask ourselves, does it make sense when we get an intercept? Here, I'll bring the intercept notes up here. So whenever you're interpreting an intercept, and great question right there. Thank you for the... We'll do that one real quick right here, because then we'll hop to some more. Class is coming up. Nice stuff. And let's take a look right here. So here's the intercept interpretation. When x is equal to 0, so whatever your x is equal to 0, we expect y to equal b0. Then we have to ask ourselves, is it logical? Send one text. Awesome. So is this making sense right here? What questions are there? Emma, does this make sense right here? When you interpret the intercept, we say when x is equal to 0, we expect y to equal b0, and then we have to ask ourselves, is this logical? Is this a logical conclusion right here to say when x is equal to 0, we expect y to equal b0? Is this logical? So we're like, is that logical? Does that make sense? When x is equal to 0, we expect y to equal b0? And then we have to know what b0 is. Remember, we get that from the output up here, where we have the equation. Let's circle it again right here in the background. So when we ask, is it logical? This one right here, and we'll do another version. Just plug in the value of 0 and kind of just talk to the person like it's a person. And if it's not logical here, we'll look at one that might not be logical. So let's go here and let's grab... This is one of my favorite classic ones to ask if it's logical. So we're just doing a classic example right here to see if something is logical or not logical. And here is the output. And first off, I want to know what the intercept is. That's different. I want to know what is the intercept. And I have it up here in the output. So what is the intercept? So just first question, what is the intercept? Not don't interpret it yet. I'll interpret it for you. So first question is, what is the intercept? Remember, the intercept is B0. So we always want to remember the regression equation is y hat equals B0 plus B1x. And so the intercept is going to be 56. And that's the x variable. The x variable will be, the y variable will be height. So that's the predicted value we're doing right here. We're predicting height. And so let's highlight right here. Height is the predicted value. The intercept, which is B0, is this right here. The slope coefficient is B1, and that leaves the x variable, which we are using to make predictions, which is weight right here. Does that make sense, Kayla, right here? Crooked scale when applying, you might have to send me your RMD. I might have to look at that. It might not have, oh, you might have done the wrong function. Double check your functions. I'll take a look at that. Oh, no. So make sure to connect all of this output right here. And then how would we interpret the intercept? And then we have to ask, well, is that logical? And then we're gonna handle this part right here. Is that logical? Ah, it is y equals mx plus b. Classic right there. We'll write that below while people try to interpret the intercept. It's basically y equals mx plus b, and we're going to circle the portions so it can make sense for what you remember from the past. This right here is the x, classic. This right here is the intercept. And remember, it's easy to remember that the intercept is when x is equal to 0. And then we need to change the color back right here. I wish Microsoft Word would let me do my pens the way I want. They changed it years ago, and I seriously need to call an executive and be like, please, let me choose the pens I want. You used to be able to add as many highlighters and stuff as you wanted. So, oh, I can't add another highlighter now because I deleted one? I'm going to delete this crayon right here. Can't delete the pencil. See, look, I can't add another highlighter. Wow, that was a dumb idea. I want to delete my other highlighters out of spite. Microsoft Word, why don't you just let me add the pens I want? I don't want pencils. Pencils are... I don't like them. When weight is equal to 0, we expect height to be equal to... Nice job right there. M100 points, as Brian just hates on Microsoft Word. That's exactly what the intercept is. Remember, the intercept sometimes might be off the scale, and so we colored the intercept in green. So this is where the intercept is at right here. And does that really make sense? And is that logical to say when someone has when people have a weight equal to 0, which is when weight is equal to 0, we expect for their height to equal 55 inches. Does that sound logical or illogical? Like, what would you say that? This sounds like a what to me because what? Like, if you just threw another little bit on there, after you say, when someone's weight is equal to 0, we'd expect their height to be equal to 56 inches, you would say, but that, like, just throwing a little bit on there to interpret it, that does not sound logical to me because individuals don't have a weight of 0. And just type that, just be like, this does not sound logical to me because people do not have a weight equal to 0. There is other instances where it is logical. We could do one where it is logical. So let's go right here. And... that's weight again. That's height. That's illogical. Where's a logical one? Okay, here we go. So this one right here, and it sounds a little bit weird, but let's go ahead and get it. We're going to grab it right here. And very important to know the notation on this screen to know what we're looking at. We're going to go to New Word document, drop it in. And we have here the equation. Let's go ahead. Our highlighters are gone. And we have here... y hat equals B0 plus B1x. The intercept here, let's highlight only the intercept, is B0, which is this. That is B0. It doesn't have the x coefficient on it. Yeah, I think so. What question is that, John? Tell me which question is. We'll do it next here. Since my quiz questions will be different than yours, like a different order, can you explain the start of the question to me? Just put a start of it and I'll do it here next. So this one would be logical, and I'll explain why. This intercept is a logical intercept. When the caret... because of price... And then... yeah, and then also... So wait, here, I'm going to delete that real quick, so since that way other people don't see it. So that way, because it's the answer. I'm saying... And I'm going to explain something else, so just go ahead. You can hit remove on the comment. And then we'll do John's question here next. But if you click on your thing, there should be like, oh, I can remove it. I don't think it'll do anything bad to you if I remove it. Wait, can I remove it now? Oh, no. Wait, Emma, did you remove it? Yeah, Emma, you're the best. No, you're fine. Don't worry. That's where I'm at. No, so Emma, here, let me explain. I'm going to go into a little greater detail for you right there. What if your person of interest, whoever you like, if you like people, I don't know, maybe some people are like, I don't want to get married ever, whatever. So, but what if the person of interest got you a 0-carat diamond? A 0-carat diamond. Does that make much sense? Like a 0-carat diamond. I think the carat is the relative size or weight of a diamond. I think it's the mass. I was reading up on it. It's a unit of like diamond mass. If someone got you, they said, here's the diamond. It's 0 carats. What would you say? You'd be like, the diamond is 0 carats. And it costs to be negative $2,000. You'd be like, just think what your brain is doing right now. Your brain's like, does not work. Here, let's tell Mubot this. Hey, Mubot, I'm getting you a 0-carat diamond. Oh, we did at the start of this one too, and I'll put it in the chat here at the end, DK. I'm getting you a 0-carat diamond worth negative $2,000, Mubot.
Error. Does not compute. Voice high-pitched.
Taking Mubot.
Mubot not working.
Invisible diamonds right there. Mubot's not happy about that, and we broke him. He didn't use the right voice. Mubot, get stuff together. Get it all together. Put it in a bag. Put it in a museum, Mubot right there. Invisible diamond, unbreakable right there. So, DK, let me go over that video for DK, and let's go check out last canvas content. Here we go. Mubot, what are you doing, man? You're not working properly, Mubot. Put on a little fun music here. We're going right here. So we got John's question right here. It's conflicting scatterplots. Ooh, that sounds fun. Let's go take a look at that. And then DK, let me grab you the visualization video. It's in the visualization playlist. I thought I said we had 43 viewers right now. I was like, no way. We got 12 viewers. 100 points to my 12 viewers right here. Thank you for hanging out. We got pretty good viewers this semester. Make sure there's a few updates to it. So make sure to follow the instructions. Follow your instructions on Canvas. Mubot's talking in the background there as we do this. Let's go to John's question right here. Last question of the day. Because then we got to teach some statistics. John asked a question about countries with issues or something. Let's take a look at this. And I'm finding the question as we talk. Just enough time. And I think we have just enough time. John says, the accompanying scatter plot. Okay. Oh, I literally clicked on it. Okay, here we go. Oh, we're good. It's a shorter one, we think. Here we go. Stat 201, accompanying scatter plot. Chapter 7 quiz. Let's do this. Okay, so we need to see if the linear model is appropriate. I'm just going to yawn. Sorry, buddy. You're yawning too right now, right? Hey, QQ straight enough. No outliers. Plot doesn't thicken. QQ, two quantitative variables. Straight enough. Straight line goes through it. No outliers. None of these are extreme outliers. Whatever. Needs to be further away. We'll try to make it more obvious. Plot doesn't thicken. You'd want to look at a residual plot for that. You can kind of look at this. A little thinner here, a little thicker. I'm thinking it's all right. I don't see any major issues. So, it's not weak. That's why I said, what? It's not weak. You notice the points are pretty close around it, so it's pretty strongish. Yeah, it's pretty good right there. The R squared is 82.6. Interpret the statistic. Blank % of the variation Y is explained by the variation X. They're not using that exact interpretation this time. But do remember, I think it's this. Where's our sheet? Here we go. Use your interpretations. Blank % of the variation Y is explained by the variation X. So let's find one. A linear model on the percentage of blank marijuana use accounts for, and this is the variation it's accounting for in Y. They're switching them. I hate that. Of the variation in the % of use of other drugs. So they're saying a linear model using this X accounts for 82.6% of the variation in the use of other drugs. So that's the R squared. I like to say 82% of the variation in other drug usage is explained by marijuana usage. That's the way I like to do it. Write the equation you would use to estimate the % of teens who use other drugs, and that's where it gets a little tricky. Hopefully we got 19 minutes to class, so I might go a little quick, sorry. And so to do this, can you do number 1? I think we did that on the, which one is that, Ashna? We might have to do that tomorrow. Is that 320 or 474? Which BAS? And we don't have time after this because I'll be teaching here in just a few minutes. But we might have done it. It's 474. We've done a lot of 474. But we will have time to do it tomorrow, though. It's 474. It's due tonight, though. So we're going to go over here. We're going to copy this data. Copy the data to the clipboard. Yes, I think we've done that. Check out yesterday's video. Check it out. And we've done a lot of 474. So we're going to copy this data to the clipboard. It has column names. Control-C or Command-C right here. So now that we've copied it to the clipboard, we can go back to Jump, which we've been using a lot today. We're going to go to File, New Data Table. File, New Data Table. And under File, New Data Table, don't click inside of it. We're going to Edit, Paste with column names. So this will paste the data in here. Now, we want to predict the other drug usage from marijuana usage. That means the other drug usage, when we go to Analyze Fit Y by X, I'll pause right here. Analyze Fit Y by X. The other drug usage will be the Y variable of interest because it's what we want to understand. Marijuana is going to be the X variable because it explains other drug usage. So we're saying, can we explain other drug usage using marijuana? X explains why something is happening. So right here, nice job, HCT. Hopefully get some more Discord help and everything right here. Thank you, HCT. 100 points right there helping out. And so now we're going to go here and fit the line, which is going to write the regression equation for us. Huge help right here to fit the line, write the regression equation, and now we have it. So here's all the numbers, tons of numbers right here. Let's go ahead and take it. The other drug usage, which is on the Y side of the equation, make sure to carry the negative. The question is wrong if you don't carry the negative number, because it's very different if you don't carry a negative number. And then we're going to take the slope of the line right here. That was the intercept, which is B0, and this is the slope, which is B1. Class is starting soon, so I'm going a little quickly. Explain in context what the slope means. The slope indicates that as marijuana usage increases, on average, the slope indicates that other drug usage increases on average by, don't love this interpretation, by this for each percentage increase in marijuana usage. I'm going to show this here really quickly, and do know these. Put these on cards, practice these. When for each 1 unit increase in X, we expect Y to increase by B1 on average. When X is equal to 0, we expect Y to equal B0. Is that logical? Good practice right there. Do these results confirm that marijuana is a gateway drug? Once again, this is like correlation is not causation, so we can't say it's causing it. So we would say right here, the result indicates an association. That is true. However, association does not apply causation. The results do not show. No, they do. Since the R value is large enough, no. We should be good. Woo! Getting scared right there. We've been going on a streak like a whole week and a half with hundreds. One of these days we won't get 100, but that's all right. We can handle it. But that's got it. Great work today, everybody. Lots of questions. We did some 474, 320. Did we do some 320? 320, where you at? 320. Where are you? Until then, everybody. Bye for now.